Okay, so welcome to week 4 in review, and this is a continuation with my series of videos for the level 1 chemistry. And the first section, which we have covered now at this stage on atomic structure, the next logical step was to take a look at what these exam questions look like. So what I did in lesson yesterday with one of the groups, and I'll do it with the rest of you guys in one day, was I just put an exam question on the board and I showed you fellas how I would approach answering it. I wrote my answer down and then I compared it with the NCEA and suggested answer for excellence, and we just compared to see how we did. And then I put the 2013 question in front of you guys. So what I'm going to do today is I'm going to do another question. So this question here I have in front of me, this is question 1 from the 2011 paper. The one I did in lesson was the 2011 sample exam paper. And hopefully you notice how similar this question is to the 2011 sample paper. So this is the actual 2011 exam paper that students sat in November 2011. And the sample paper question is pretty much a carbon copy of what this question is. The only difference was they changed the elements that they're talking about. You can see the structure is the exact same. You have to describe an ion, whereas in the sample paper they said define what an ion is. You have to describe the atomic structures of a sodium ion and an oxide ion, which was necessary in the sample paper in 2011. The charges on the ions, and then explaining the charges in terms of electron arrangement and number of protons. It's a very, very similar question to what the 2011 sample paper was like. In which case, they probably won't have a sample paper for 2014. The only reason they put a sample paper up in 2011 was because the course changed that year and they needed to have some sort of an exam paper to give guidance to teachers and students. But the point I'm trying to make here is that if that's what the 2011 exam paper looked like, was a question on ions and atomic structure and basically using atomic structure to explain the ions that elements form. The exam paper in 2013 that I put in front of you guys yesterday looked like this. So it's the same content that they're assessing, it's just they've changed the format slightly of the question. So you've given 3 different things here. You're given fluoride, which is F minus. You're given neon, which is an atom. Remember, if it has no charge, then it's an atom. And then a magnesium ion, Mg2 plus. And they all have the same electron arrangement, which is interesting. And they give you this table to fill out, and they tell you to use your periodic table as a resource. So I've also got the resource booklet open here as well, and we'll use that where appropriate. The resource booklet is in green there. You can see the text. And if we scroll down through it, there's level 1, 2013. So I just grabbed this from this year's exam paper. Demonstrate understanding of acids and bases. Remember, there's 3 sections to this exam paper. The first section 1, I've identified as being atomic structure. So that's all about structure of atoms and how they form ions. So that's what I like to refer to as section 1. Section 2 then for acids and bases. Section 2 is all about chemical reactivity. Chemical reactivity, which I will start teaching you guys next week. And section 3 is essentially the real acid and base stuff, acids and bases. So we will do that in term 3, I think it is. So we need to do these 2 sections. And I've covered the first section with you guys. This is the final video on it. And then we'll do section 2 probably within a week and a half, starting next week. So I'll have the resource booklet open, and the resource booklet, I just wanted to use this because it's a bit more official than what's in your student workbook. So I've made this point in class that the table of ions, let's go back up there for a second. Table of ions that you get, here it is, on the resource booklet doesn't have any names with the ions. So you have to be capable of going through this table of ions and saying, this one is ammonium, this is sodium, potassium, silver, and hydrogen ions. Calcium, magnesium, copper, lead, iron, barium, zinc ions, aluminium, iron 3 plus ions. O2 minus is oxide, S2 minus is sulfide, CO3 2 minus is carbonate, SO4 2 minus is sulfate, OH minus is hydroxide, chloride, nitrate is NO3 minus. Hydrogen with carbonate is called hydrogen carbonate, and Fi minus is fluoride. So you need to be capable of doing that. Okay, so that was a general overview of what I'm trying to achieve here. I'll do question 1 from the 2011 paper. I haven't even looked at the assessment schedule, which I have open up here So we look at that afterwards just to make this as fair a test as possible. Um, in lesson, I said that the best way to approach answering these questions is to first of all read through the question. Now, I also left up here the fact that you have 60 minutes to do 4 questions. And if you split that evenly, you would say, well, you should have 15 minutes to answer each of the 4 questions. But in reality, you'd want to be working to a 13-minute deadline maximum, because you should give yourself 2 or 3 minutes at the beginning of the assessment to read through the entire paper and rank your questions, first being your best one all the way to fourth being your worst question. You can tell that pretty quick from just reading a question which one is going to be a worst question. You do your first one first, your best one first, and do your worst one last. For the simple fact that you must get off to a good start just to build your confidence, and then that eases the panic. Panic stops people doing stuff they know they can do. So that's the first thing. So 13 minutes to do a question. So I'll try not to take more than 13 minutes to answer this. And to be honest, it'll probably take you about 6. Explain why ions formed by sodium and oxygen both have the same electron arrangement. In your answer, you should describe an ion, describe the atomic structures of a sodium ion and an oxide ion, state the charge in the sodium ion and the oxide ion, and explain the charges in both ions in terms of electron arrangement and number of protons. Now, to describe an ion is really an achieved skill at best. You're basically defining an ion and writing everything you know about ions. Describing the atomic structures of sodium ion and an oxide ion, it's an achieved borderline merit skill depending on how much detail you go into. State the charge in the sodium ion and the oxide ion, that's definitely an achieved skill. I mean, you can look that up just by simply going to the resource booklet, and you look up your sodium ion is right there, has +1 charge, and your oxide ion has a -2 charge. So that's given to you on your exam paper. So if you can't do that, you're really struggling. So that's an achieved type skill. Explain the charges on both ions in terms of electron arrangement and number of protons. Anytime you see the word explain in NCEA, that typically means excellence or at least merit for that answer. So bear that in mind. So in lesson, I said the first step I want you guys to do is to always read through the question in its entirety. The second thing is then you go back through the question and you just start to annotate or write over it anything that you can, anything that makes sense, because you might pick up marks just for annotations. So ions. As soon as I see the word ions as a key term, I know they are charged atoms. So just write that beside it. Sodium has the symbol Na. Oxygen has the symbol O. They both have the same electron arrangement. Now, electron arrangement is where you write 2, 8, blah, blah, blah. So that's the electron arrangement. So you're going to have to write that at some stage as well to support your answer here. In your answer, you should describe an ion. Okay, so an ion is a charged atom. I've just already written that. Atomic structures of sodium and oxide. Now, atomic structure is not just electrons alone. So that's neutrons, protons, and electron arrangement, okay, for a particle. So when you see atomic structure, you need to be also talking about neutrons and protons, not just electrons. Electron arrangement is just for electrons alone. The third bullet point is state the charge in the sodium ion. Well, I know it's Na+, and the oxide ion, which is O2-. And as I say, we just found that on the resource booklet, sodium Na+, oxide O2-. Go back to the question here. Explain the charges on both ions in terms of electron arrangement and number of protons. Well, basically, both ions are, well, the sodium is plus, which means that there's one more proton than electrons. So the proton number is greater than electrons because this stuff is positive and this stuff is negative. So you have an overall positive charge as a result. Whereas for the oxygen situation, which is O2- oxide, the proton number should be less than the electron number, and that means you have an excess of negative charge on the oxygen. Easily illustrated if you write down the electron arrangements. So this is a new thing that the NCEA guys, well, they brought out in the 2011 shift, was that they started to give bullet points to help you guys structure your answers. And I said this in lesson, if you don't divide your answer up into these 4 sections, you're really making it awkward and difficult on the examiner to find how you're answering the question. And if you start to do that, you're not helping yourself from the beginning. So the first thing is I'm going to just put down a bullet point here, and this will match up with the first bullet point, which is to describe an ion. Now, in lesson yesterday, I said if you can describe an ion simply as an ion is a charged atom. And some of you might be happy with that definition, and I would be quite happy with that definition, but we could write more. Now, the golden rule with NCEA is if you can write more to support your answer, then do it. So an ion is a charged atom. They can be positive, which are known as cations, e.g. sodium ion, or negative, which are anions. An example in this case would be O2 minus oxide. What else can we say about ions? Atoms form ions. Atoms form ions in order to be more stable, and that is, i.e., to have a full outer shell, outer or valence shell. So that is why atoms form ions in the first place. I'm just going to scroll down a bit here now. That's why atoms form ions. An ion is a charged atom. They can be positive cations, e.g. Na+, or negative anions, e.g. O2 minus. Atoms form ions in order to be more stable, i.e. to have a full outer shell or valence shell. And you could also say, note, group 18 elements don't form ions. As they already have a full outer shell. They already have a full outer shell. An example would be neon. Okay, so as far as I'm concerned, I've done that first bullet point to describe an ion. Describe the atomic structures of a sodium ion and an oxide ion. So we've got to do this now. I'm going to get a new page just for this. So I have a bit more space. Okay, so let's go back to the question. It said, describe the atomic structures of sodium and oxide ions. So let's just put them side by side here. Sodium ion is Na+, oxide ion is O2 minus. If we need to look up sodium now, so number of protons, neutrons, and electrons, and for oxygen we need to know the number of protons, neutrons, and electrons as well. So if we go to our resource booklet, which is right here, the atomic number, let's skip down the periodic table here. The atomic number for sodium is 11. You notice that they haven't given the mass numbers here on this periodic table, in which case we can't actually do anything with the neutron number. So the proton number for sodium is 11, which means that the atom, if we just do the atom first, the atom itself would have had even numbers of electrons and protons, so 11 of each. For an oxygen atom, let's just stick with this initially, the oxygen atom would have had atomic number 8, so it would have had 8 protons and 8 electrons. So this would be the neutral situation, because 8 positive and 8 negative gives you 0, 11 positive, 11 negative gives you 0. So that's the neutral situation. Now, atomic structure then, we need to also know the row number. We need to also know the group numbers. So group number, row number. And we just do that for oxygen as well. Resource row number, remember hydrogen is row number 1, so this is number 2, number 3. So sodium is in row number 3, which means it has 3 shells. So row number 3, which gives you 3 shells. And it's in group number 1. You can see it there. Groups run down this way. Group number 1. Oxygen is in group number 16 and row number 2, 1, 2. So row number 2 for oxygen means it has 2 shells. And group 16, which means it has 6 electrons, 6 outer shell or valence shell electrons. Sodium is in group number 1, which means it has 1 valence electron. Okay, so we're building the atomic structure now. So in the nucleus for a sodium atom, it would have 11 protons, 11 positives. We don't know how many neutrons because our version of the periodic table didn't give us that. So that's the nucleus right there. For oxygen in the nucleus, we have 8 protons and a certain number of neutrons we don't know. And that's the nucleus there. Just use a different color for the shells. So we have 3 shells for sodium, 1, 2, and 3. For oxygen, we have 2 shells, so 1, 2. And then if we look now at the electron arrangement, 2 electrons in the first and 8 thereafter. So for a sodium atom, you have 11 electrons, so 1, 2, then 1, 2, 3, 4, 5, 6, 7, 8, so that's 10. And then your 11th electron for the sodium atom is the one of interest, and that's your 1 valence shell electron. Your 1 valence shell electron, which you know from it being in group 1. Oxygen atom has 8 electrons, 2 in the first, and then 6. 1, 2, 3, 4, 5, and 6, which matches up with the 6 valence shell electrons right there. And this hopefully helps to explain why the electron arrangement for a sodium atom goes from 2, 8, 1 for the sodium atom. It goes to 2, 8 for the sodium ion. So it loses this outer shell electron. Whereas for the oxygen atom, it goes from 2, 6 for the oxygen atom to 2, 8. Because it needs to gain 2 extra electrons in order to get the full outer shell. So let's go back to the question just to check that we're actually answering what we're supposed to do here. So describe the atomic structures of a sodium ion and an oxide ion. So we're nearly there. I'm doing this in a long-winded way, I suppose, but it's the more detail, the better. The atomic structure then for the oxide ion is going to be still going to have 8 protons, but for electron number now you're going to have 10 electrons because we just gained 2. So therefore the charge overall is going to be -2, and this actually helps us with the last part of the question. Sometimes I do this, I answer the whole question in one go. You just have to be careful with that. For the sodium ion, you still have the same number of protons, 11, but your electron number has reduced from 11 down to 10, which gives you an overall charge of +1 on the ion, which is up there. Overall charge is -2 for the oxide ion, which is up there. So atomic structure, well, basically it's going to be the same diagram as here, but you now have 2 extra electrons, which you can just put in there in yellow for oxygen, and whereas for sodium, you just remove that electron right there. So let's go back to the exam question. So describe the atomic structures of a sodium ion and an oxide ion. Now maybe the best way to answer that would have been to use text, and I'll probably get done on that in the answer. So we'll take a look at the answer in a second. So you do need to be wary of that. That drawing diagrams is fine, but for NCEA you really need to make sure you back it up with text. State the charge in the sodium ion and the oxide ion. Well, I've covered that already. And explain the charges in both ions in terms of electron arrangement and number of protons. Well, what I'm going to do now is I'm going to use this answer which I created here, which was very good, but we need to add the appropriate text. So here we go. So the appropriate text to support what I've just described essentially in diagrams is as follows. So in the sodium ion, the charge is +1 because you have 11 protons with a positive charge of +11 and only 10 electrons with a negative charge of -10. Overall, the charge is +11 - 10, which is equal to +1. And then for oxygen, in the oxide ion, comma, the charge is -2 because you have 6 protons. Let me make sure I get this right now. Go back up. 8 protons. I have it in my diagram there. So you have 8 protons and plus charge, positive charge, and 10 electrons, giving a charge difference of -2. So the benefit of doing the diagram is it uses electron arrangements to support your answer. And if we look at the question again, explain the charges in both ions in terms of electron arrangement, which I've done, and number of protons, which I've just mentioned. So as far as I'm concerned, I've written everything I could to answer that question. Now let's take a look at the sample answer for this question. This is the 2011 sample answer. Description of an ion. An ion is an atom or group of atoms that has lost or gained electrons and therefore carries a charge or a full outer shell and stable. So stable, full outer shell needs to be mentioned, and they also carry a charge lost due to loss or gain of electrons. Explanation of charges. Sodium has 11 protons and the electron arrangement is 281. Sodium has 1 electron in its outer shell which it loses. Covered that. So its outer shell is full to become 28. It has a charge of +1 as it still has 11 protons, which are positive charges, and now only has 10 electrons, which are negative charges. Oxygen has 8 protons in the electron arrangement 2, 6. Oxygen has 6 electrons in its outer shell, and so it gains 2 electrons. So its outer shell is full, 2, 8, and so has a charge of -2, as it still has 8 protons and now has 10 electrons. And evidence may come from diagrams, so we're okay at drawing diagrams, so that's good to know. And then you can read yourselves what the difference is for achieve merit or excellence. But for excellence, you essentially must be very comprehensive and cover everything, almost everything, which is in the sample answer there. Now we'll move on. That took me a little bit more time than I thought it would, just because I'm stopping and starting. If I look at the question in 2013, let's just see how similar it was. Well, in 2013, you're given a question involving fluoride, neon, and magnesium ions, and they have the same electron arrangement. And so let's just take a look at that. So atomic number needs to be looked up for each of them. The atomic number for fluorine, I need the resource sheet here. Atomic number is 9, and neon is 10. So let's just get these down on paper. So fluorine 9, neon 10, and magnesium, the atomic number is 12. So that is 12. The number of protons is gained from the atomic number, so 9 protons. Neon is 10 and magnesium is 12. Number of electrons for neon is going to be the same as its number of protons because it is an atom. This is an ion, specifically an anion, and magnesium is a cation. The number of electrons for fluoride rather, it should be 9, but because it has a negative charge, it means it has gained 1, so it's actually 10. So let's put this in a different color. So it's actually 10. And because magnesium has a +2 charge, which means it's loss of 2 electrons, then this means that its electron number is 2 less than its proton number, which is 10. Electron arrangement. So the same electron arrangement is what it says up here. So if you can do it for neon, it should be the exact same for the others. So for neon, number of electrons is 10, so it's 2 in the first and then 8 in the second. So all of them have 10 electrons, so that's why the electron arrangement is all the same. So that there would probably be an achieved skill at best. Okay, let's move on to the second part of question 1 from 2013. And this is where it starts to repeat itself, just like we did for the 2011 question. Okay, so here, what is the question then? Part B. Compare the atomic structure of fluoride, neon, and magnesium. In your answer, you should describe the difference between an atom and an ion. So we've done that before. Explain the charges on fluoride, neon, and magnesium in terms of electron arrangement and number of protons. We just did that in the last question. It's just that they're getting it for you to do it by 3 this time instead of 2 times in 2011. Relate the position of fluoride, neon, and magnesium on the periodic table to the charges and electron arrangement. So this is basically the idea of group number having an influence on how many electrons you're going to lose or gain, and explain why all three have the same electron arrangement. Okay, so I'm looking at the time in this video and it's running quite long already, so I will do a quick answer to this question just because the 2013 paper, the answer schedule for it won't be posted until well into this year, for the simple fact that there's still students trying to contest whether their answers are fully that they're satisfied with the marking of their answers. So I will just provide a quick answer to this, and then we'll finish the video up on that, I think. Difference between an atom and an ion. An atom is atoms are neutral particles. We've covered this many times at this stage, where the number of protons equals the number of electrons, whereas ions are charged particles. And they're charged particles because the number of protons is not equal to the number of electrons. Explain the charges on fluoride, neon, and magnesium. Well, fluoride atom, the electron arrangement would be 2,7. Fluoride ion is 2,8. So it has gained one extra electron. So the proton number of fluorine, you can tell just from the electron number in the atom is going to be 9. So if you have 9 protons and then you have 10 electrons, well then the overall charge is going to be -1, and that's why the charge in the fluoride ion is -1. For neon, is neutral. So neon is neutral. Neon has the electron arrangement 2,8. It has 10 protons and it has 10 electrons. So plus 10 minus 10 equals 0. So all atoms are neutral. And then for magnesium, it has a +2 charge, and that's because it has lost 2 electrons. So magnesium atom's electron arrangement is also 2. Let me just check this now. Magnesium, 12 electrons, so it's going to be 2, 8, 2. So go to the right spot. Where are we? 2, 8, 2. So magnesium would have been 2, 8, 2, but it loses these 2 electrons. So therefore it becomes magnesium 2 plus, and then it's going to be 2, 8. So its number of protons was 12 protons. And now it only has 10 electrons. Minus 10 electrons will give you a charge of +2. So that's why the charge of the magnesium ion is +2. So that's what you would need to do there, but you'd have to back that up with text, and I can show you. I'm sure you guys can do that now based on what I just said for the 2011 question. Relate the position of fluoride, neon, and magnesium on the periodic table to the charges and electron arrangement. Well, fluorine, we look at the groups now, so fluorine, neon, magnesium. Fluorine is in group 17, or group 7 you can also refer it to, so it needs 1 more electron for a full outer shell. So therefore it forms the fluoride ion. So any of these elements, fluorine will form fluoride, chlorine will form chloride, bromine will form bromide, iodine will form iodide. So all group 17 elements will just gain 1 more electron. Magnesium is in group 2, so it will lose 2 outer shell electrons and therefore form a charge of +2. For anything in group 2 will form a charge of +2, beryllium, magnesium, or calcium. And neon is in group 18. It has a full outer shell, 8 electrons, so therefore it will not ionize at all. So that's what they're getting at there in that particular bullet point. And then explain why all 3 have the same electron arrangement. Well, they all have the same electron arrangement because they have the same number of electrons available to arrange, and the arrangement is always 2 in the first and then 8 in the second shell if you have 8. The only other thing I wanted to look at then, because this week we did a lot of good work on writing ionic compounds which are neutral, so I want to just find a question which is related to that. Okay, so this is the last question that I'm going to do today, because it's the only other type of variation that I can see that you can get in your question in atomic structure. Otherwise, they start repeating themselves just by changing the elements, as I say. So element X is between numbers 11 and 18 on the periodic table. So let's just highlight 11 and 18. So group 11 is right there, and 18 is over there. So we're focusing on this section. And remember, we only go down to row 4 with calcium. We don't even go, we stop at calcium right there, so you don't have to consider any of these elements. You're looking at something in this block right here. All right. So let's go back to the question. So element X is between numbers 11 and 18 on the periodic table. Or let me just reread that. So it wasn't groups. It didn't actually say groups. It said numbers. So I presume that's atomic number they're talking about. So numbers 11 and 18 would actually be not what I highlighted there originally. So let's delete that. What they're talking about is atomic number, I'm guessing, 11 to 18, which is right there. So somewhere in there, we're considering one of these elements. And the question continues to read, an atom of element X forms an ion. This ion combines with the hydroxide ion to form a neutral compound, and X, and then 3 hydroxides. Well, the charge in the hydroxide ion, we're going to need our resource sheet. So our resource sheet tells us that the charge in the hydroxide ion is -1. And if you need 3 of these, then the cation X must have a charge of +3. If it takes 3 of the hydroxides to satisfy that, that would be +3 -3, which would be 0. And that's where they're getting their XOH3. So we know that the element X must have a charge of +3. Let's go back to the question. So an atom of the element X forms an ion, which must have a charge of +3. This ion combines with the hydroxide ion to form a neutral compound XOH and 3 of them. Determine what element X is and justify your answer. In your answer, you should consider the ratio of X ions to hydroxide ions. Well, the ratio is 1 of these is to 3 of the hydroxides. Because you can see there we have 3 of them. Remember, we use brackets if it's a polyatomic ion that we're trying to show multiples of. Use the formula XOH3 to determine the charge of the X ion. Well, I said it was X3 plus. And then explain how you would use the periodic table in your resource booklet to find out which group element X is in. Well, element X is in group, let me just see the resource booklet now. It's going to be in group 13, because if you're in group 13, you will lose 3 electrons from your outer shell, and then you'll have a full second shell, and that will give you a charge of +3. Group 14 elements don't ionize. We've talked about this in class before, so you wouldn't consider carbon and silicon in the first place. Group 15 will gain. They will gain 3 electrons because it's easier to gain 3 than to lose 5. Group 16 will gain 2 instead of losing 6. Group 17 will gain 1 instead of losing 7. So it has to be in group 13, and since we're dealing with elements from atomic number 11 to 18, it has to be aluminium. Has to be aluminium. So we go back to the question. Name the element. The element is aluminium. So aluminium is in group 13, comma, it will lose 3 electrons. It will lose 3 electrons, forming a cation, Al3 plus, 3 hydroxide ions or particles are needed to combine with 1 Al3 plus ion in order to form a neutral ionic compound. And so what you're essentially doing here is you have 1 aluminium ion, which is a charge of +3, and let's just draw it as a large particle. And then we need 3 hydroxides, 1, 2, and 3, in order to satisfy that +3 charge. So the total charge here will be +3 from the aluminium, and the total charge here will be -3 from the 3 hydroxides, and that will give you a neutral ionic compound. If we want to use a little bit about electron arrangement here as well, the proton number for aluminium is, let's just check its atomic number now. Proton number for aluminium is 13. So we have 13 protons, and the electron number is now 13 minus 10, because originally the aluminium atom would have had 13 electrons, but we've just lost 3 to ionize, so the electron number is now 10, so it's +13 minus 10, which gives you +3. So that explains why the charge in the aluminium ion is +3, and it does that because it's in group 13. So let's take a look at what the assessment answer was for that in 2011. Take a look at that now. The ratio is 1:3. Hydroxide ion has a charge of -1 because there are 3 hydroxide ions overall. The total negative charge is -3. Therefore, to form a neutral compound, X must have a charge of +3, as there is only one X ion in the formula. Therefore, X loses 3 electrons to a charge of +3. So we covered all that. How to find group for X? The only element between 11 to 18 that has 3 electrons in its valence shell is aluminium in group 13, or it must be in group 13 to have 3 valence electrons. What is X? X is aluminium. So that's just another alternative thing they can assess you on in the atomic structure question. And we did good work on writing combining the various ions from the table of ions and to form all different ionic compounds that you can form. So hopefully you can see from that long video that the only thing that can really change from year to year now is the identity of the elements that they're talking about. Otherwise, the question is the exact same from year in to year out. So if you can watch this video and practice answering these questions in your own time, you will do okay on this question.